So in this session we will see what is actually Bayes rule and how do we apply this Bayes rule to the documents and classes, or specifically how this Bayes rule is applied to the text classification. So this P of C given D is equal to P of D given C dot P of C divided by P of D is actually derived from with the help of another formula, that is P of D given C is equal to P of D comma C divided by P of C, right? That is the joint probability of C and D divided by the marginal probability. So going back to the problem of again, the problem of bag and balls. Suppose we had this large bag. Okay, so we have this as and we have one smaller bag. So this is bag 1 and this is bag 2, and we have some red balls in both these bags, and we have some black balls here, and we have some green balls here, right? So we write as the probability P of, in the previous session we did like P of red given bag 1, right? So this is actually the shorthand notation. The complete notation I am writing now so that it makes it more clear for future purpose. So P of ball, so this ball is actually a variable here, and I am taking it ball is equal to red. So this is the value of this. Red is actually the value of ball variable. So ball is actually a variable, and ball can be red or green or black. Similarly, we can have another variable, that is bag. So this bag can be either bag 1 or bag 2. So these both are the random variables. Okay, so we don't know actually which one of the bag or which one of the ball we will be picking, and the probability we will be calculating with the help of these probability rules and Bayes theorem and all. So P of ball is equal to red can be calculated as ignoring these internal representation of these bags. Just we will ignore that there is some internal representation, right? And then we will calculate the number of balls as red collectively divided by the total number of balls, right? So this can be written as total number of balls, of red balls collectively in both bags divided by total number of balls. So that is equal to 4, and that is 3 plus 1 divided by, and this is 8 plus 8, so that is 16. 8 plus 8, so I can write it as 4 by 16, that is 1 by 4. Similarly, we can calculate the ball is equal to green, ball is equal to black, right? So let's directly write P of ball is equal to green is equal to 8 divided by 16, that is 1 by 2. P of ball is equal to black is equal to 1 by 4, and we see that we add up all these three together. We take this and take this, and we perform the summation is equal to 1 here, right? Now let's take a P of ball is equal to red. Before going that, let's take off P of bag is equal to bag 1. So we are just having only two bags, there is no discrimination between the two bags, both are identical, so we are having just probability as half. Similarly, we are having P of bag is equal to bag 2 is the probability of half. So we now again take the summation of these two, right? So this summation again is equal to 1, right? So these are called as the marginal probabilities. Now let's go on to the conditional probabilities. P of ball is equal to red given bag is equal to bag 1. So this is now we are looking this into the perspective of bag 1 only. So we get 3 balls here, and the total number of balls in bag 1 is 8, right? So let's take up this same thing as equal to P of probability of ball is equal to red, comma, bag is equal to 1, bag 1. So this is the joint probability divided by P of bag is equal to bag 1, right? So we define the conditional probability as this is suppose P of A given B. So this is equal to P of A comma B divided by P of B. So this is the formula for conditional probability. So in this case, in this 3 by 8, we are just directly looking into the bag 1, right? I am saying that when we condition it on bag 1 or condition it on some subset, we just ignore all the other things and just we go into that subset as a whole, right? And then we calculate the probability for this particular variable, random variable, for ball is equal to red, and that is the conditional probability for the whole set, right? But we can also calculate the same thing by using this formula P of A comma B, that is the joint probability of A and B divided by the probability of B. So P of ball is equal to red and P of bag is equal to bag 1. So what is actually the joint probability? So again, this joint probability may be again represented with the help of some table here. So I must draw the table like this. This is bag, and bag is equal to bag 1, where bag can be equal to bag 2, and this is ball. So this is equal to red, this is equal to blue, and this is equal to black, right? So what is the probability that ball is red as well as the bag is 1, right? So this place is actually the ball is red as well as the probability, both are occurring at the same time, right? So this 1 by probability of red in bag 1 is 1 by that is 3 by 8, and the bag 1 is the probability of bag 1 is half, right? So since these two events are independent of each other, we can write that P of A dot B is equal to P of A dot B, right? So we can have this blue ball is red, blue, red, green, black. So we have the green one here. This is green. So green is bag 1 is these all are 1 by 2, 1 by 2, 1 by 2 and 1 by 2. So in bag 1 it is 3 by 8, it is 4 by 8, it is 1 by 8, this is again 1 by 8, this is 3 by 8, green is 4 by 8 and this is again 3 by 8. Alright, so we should sum up all these three and the total should be equal to 1, right? So this is 3 plus 4 plus 7 is 8, that is equal to 8 by 8, right? So if I am taking the summation of these three, so this is 3 plus 4 7 plus 1 8 divided by 8 into 2, that is 16, so we get a half here, right? We get a half here. Similarly 1 plus 4 is 5 plus 3 8 divided by 16 is again we get a half here, right? So all these collectively, all these probabilities should be equal to 1, right? So but if there is some biasing here, I come to know that bag 1 is related to red ball, then this can't be applied because I have taken the condition that the probability of ball is equal to red and the probability of bag is equal to bag. These are independent of each other. Whether I select any kind of ball and select any kind of bag, they do not affect each other, right? So the probability of ball is equal to red. So with the help of now this formula, this is actually related with directly I am calculating, right? And now I will be calculating this by relating with this. So this is equal to ball is equal to red and bag is equal to bag 1 is 3 by 16. 3 by 16, bag is equal to bag 1 is 1 half, so this is multiplied by half, so that is equal to 3 by 8, right? So this is both these are same. So we can just intuitively go by looking into the problem and then we can directly say that I am going directly to the sub problem and just applying the counting method, subset going to a subset and just counting, or you can use this kind of formula based and then proceed by calculating this calculating this conditional probability, right? So this we have P of ball is equal to red given that bag is equal to bag 1. So we have P of ball is equal to red given bag is equal to bag 1 is equal to 3 by 8. So we need to calculate the reverse of this, right? So the reverse of this, what is the probability of bag is equal to bag 1 given that ball is equal to red, right? So what does these two mean? It means that I am first given that the bag is bag 1. Now what is the probability of ball is red? Okay, it means that I am given the only bag as bag 1. What is the probability of red? I am saying 3 by 8, right? Now I am saying that given that I am picking up a ball, so by closing my eyes, what is the probability that bag is bag 1, right? I am picking the ball from this collection of bags by closing my eyes, and then I am asking what is the probability that the ball I have taken out is taken out from the bag 1, right? So this can be calculated with the help of this base form, not this one, sorry, this base formula, right? So I write it as P of ball is equal to red, given that bag is equal to bag 1, multiplied by a probability of bag is equal to bag 1 divided by the probability of ball is equal to red. Right, so this is P of C given D divided is equal to P of D given C dot P of C divided by P of D. So we can write P of D given C is equal to P of C given D multiplied by P of D divided by P of C. Right? Multiplied by P of C given D. Okay, so this is the reverse one here. So finally we are actually calculating the class. So P of C class given document, right? We want to identify what is the class given a piece of document given a piece of document, right? I want to know which class does it belong. That can be calculated from the probability that given the class, what is the probability of document multiplied by probability of class divided by the probability of document, right? So C given D is D given C multiplied by C divided by D, right? So this formula can be extended. This formula can be extended again this is again the short form. I would like to write it in complete form as P of class is equal to C, right? Given document is equal to D is equal to P of document is equal to D given class is equal to C. So I must write DI and CJ so that it's one of these classes and one of these documents. So dot P of just a moment. Hello. क्लास चल रही है. Okay, so P of document is equal to D, class is equal to C, and P of class is equal to CJ. Here this is also CJ, this is DI, and so these classes and documents are variables, and the CI and CJ and DI are actually the values of those particular variables. So P of document is equal to DI. Right. So now getting back to these ball and bag problem, so I need to calculate this. P of bag is equal to bag 1 divided by ball is equal to red is equal to P of ball is equal to red given bag is equal to bag 1. So P of ball is equal to red given bag is equal to bag 1 is 3 by 8. So this value is this is 3 by 8, right, multiplied by bag is P of bag is equal to bag 1. We are having 2 bags and the probability of bag 1 is half, so multiplied by half divided by ball is equal to red. So ball is equal to red, so we calculated ball is equal to red here as 1 by 4 divided by 1 by 4. So this is equal to 3 into 4 divided by 16, so 12 by 16, so that is 3 by 4, right? So this value we are getting for this probability with the help of this Bayes theorem, right? So what happens in this class of in this problem of text classification is that from the given set of documents, we are having this given set of documents, we are having this given set of documents, we are having this given set of documents D1, D2, D3, or in general we may write D1, D2, dot 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 Di, and we have some number of documents, say we have M documents here, and we are having assigned classes. So this is C1, C2. The C1, C2 are among the fixed set of classes. Suppose I am having only two classes, spam or not spam, right? So C1 may be spam, C2 may be not spam. So again, this is assigned as C1, this is assigned as C2, right? So probability of this document given class can be calculated from this table. How we can calculate? We just put these documents in this like bag, the same bag and ball problem. We make a bag of class 1. We make a bag of class 1 like this. This is the class C1, this is the class C1, or I may write it like this. This is the class C1, and this is the document D1, this is the document D2, and this is again another bag. This is the class C2, this is the document D, suppose DI and DM, right? So now from here we can calculate the probability of D1 given this class, right? So I just go directly into this particular bag and calculate the probability of D1. I go in this particular bag of class C2, I calculate the probability of this particular document, or vice versa, or the other way around, we can calculate the probability with the help of this formula, right? P of ball is equal to red, comma, bag is equal to bag 1 divided by P of bag is equal to bag 1 as P of document is equal to document 1, comma, class is equal to class 1 divided by the probability of class, right? So we can do the both ways, right? Both ways are correct. So we get this probability document is equal to Di with the help of class is equal to Cj, just by going into that particular bag of class and calculating the probability of document. And we can directly calculate the probability of class is equal to Ci. We are having two classes, so we can so here the probability of class will not be equal to half, because the probability of class is actually determined by the number of documents present in one class, right? So if this class C1 is containing say 2 documents, the number of documents is 2 here, the number of documents is 5 here, right? The number of documents in class 1 is 2, and the number of documents in class 1 is 2, and the number of documents in class 2 is 5. So we have this probability of class 1 as 2 by 7 and the probability of class 2 as 5 by 7, right? And this probability of this document is equal to Di can be calculated just by taking this document divided by the value of this document, or the counts of this document divided by the total number of documents, right? So the probability of D1 is equal to the count of D1 divided by the all the total counts present in all the documents, right? So in this way we can just apply the Bayes theorem to the text classification. Hope you understand. So the rest we will continue in the next class.